All right, so at this point, I'm hoping you've practiced everything else because now what we're going to do is make them confusing by adding all the things. So you could get some product rules, some quotient rules, some power rules, some negative exponents, some zero exponents, and they can all be thrown in together. And the question is, what do I do? So all we're going to be doing here is simplifying each expression so that no negative exponents appear in the final result. That's the most important thing. When I look at this first question, I hope you see a product rule, or sorry, a power rule, but you also see a product rule. Well, exponent laws follow BEDMAS. So I'm going to do the exponent first, followed by the multiplication. So the first thing I'm going to do is that this is x to the negative 12, right? So I multiply the exponents. Now times x to the negative 5. Some people might look at this and be like, oh, a negative exponent, I'm going to take it to the bottom. Sure. Or you could just be like, hey, product rule. When multiplying powers of the same base, I'm going to add the exponent. I end up with x to the negative 7, which if I want to answer with a positive exponent would be 1 over x to the 7. Okay, let's amp it up one more level. So this question, very similar to this one, except I've thrown a coefficient in there. What does that mean? Well, first thing I'm going to do is my exponents. So I've got negative 2 times m to the negative 1, and then I'm going to do this as m to the 6. Then, when multiplying powers of the same base, I add the exponents. So this would be negative 1 plus 6, which is going to leave me with negative 2 times m to the 5. Is there anything more to do? No. I don't have any negative exponents. I never had to deal with my negative exponent because it just got absorbed in the m to the 6. And this negative coefficient is fine. It's not a negative exponent, it's a negative coefficient. All right, moving on to the next one. In this one, I have a power rule twice, so I have the power rule here. I also have this power rule which has to apply to everything in this bracket. So that's going to give me 3 squared, and then I have p to the negative 8 because I multiplied those exponents. And remember, this is 3 to the 1, so it was 1 times 2, right? And then I have p to the 3 times negative 1 is negative 3. Then I'm going to evaluate the 3 squared, so I'm just going to put 9. Then I'm multiplying powers of the same base, so I'm going to add the exponents. So negative 8 plus negative 3, which is going to give me 9 times p to the negative 11. And then I have to deal with that negative exponent. So the 9 would stay where it is. The p to the negative 11 would go to the denominator and become a p to the positive 11. All right, next two questions. In the next two questions, we've thrown in some negative exponents and quotient rules. When you look at this one, again, up to you what you want to do. There's more than one way to start this question. Some people might look at this and be like, I'm going to simplify inside first. I've got 4 and a 24. I've got m to the 5 divided by m to the 1. I've got n to the 4 divided by n to the negative 7. And some people might simplify that. Some people might go, ooh, I have a power rule, so I'm going to multiply this negative exponent through. Some other person might look at this and be like, hey, you know what? This is a negative exponent on a fraction. I'm going to flip the entire fraction to make this a positive exponent. What do you want to do? And I hate to say it, but it is a choose your own adventure. Now, this is a video where I don't get to see your work, so I have to just sort of choose a way for you to do it. And to be honest, I'm a little torn. What should I show? What should I do? I think I'm going to deal with the negative exponent outside first. I'm kind of, for some reason, I like flipping right now. So I'm going to flip everything. Now, when you flip it because of this negative exponent, nothing in here changes. So this would be 24mn to the negative 7 over negative 4m to the 5 n to the 4. And now this is all raised to the exponent 2. Now what should I do? Well, I could put the 2 through if I wanted to, but I'm kind of looking at this 24 and thinking, oh, I don't want to do 24 squared. So instead, I'm going to simplify inside, right? You'll get the same answer as me if you put the 2 through. But I'm going to divide. So I've got 24 divided by negative 4 is negative 6. Then I've got m to the 1 minus 5, which would be negative 4. And then I have n to the negative 7 minus 4, which is negative 11. If you want to show that step, like the subtraction, please feel free. And then this is all being squared. Maybe now I want to deal with the negative exponents, put them on the bottom. Maybe now I want to put that exponent of 2 through. It's up to you. I'm going to put the exponent of 2 through. So I'm going to put negative 6 is being squared, m to the negative 4 is being squared, and n to the negative 11 is being squared. That would give me negative 6 squared would be 36. Then I have m to the negative 8, n to the negative 22. So then I have to make both of those exponents positive. 36 would stay on top, the m to the 8 would move to the bottom, and the n to the 22 would move to the bottom. And again, no one way to peel this potato, right? So I just showed you an order of operations that I might do, but the second time I do this, I would probably do it differently, right? I have a tendency to change the way I do things every time I do it. This is just the way that looked easiest for me this time, but you choose. All right, let's look at this next one. What would I do? Well, I'm not going to care that this exponent's negative, although I could take everything to the bottom, but I'm just going to put it through because I feel like that's going to be easiest. So using my power rule, this would be m to the 2 times negative 2, which is negative 4. This would be n to the 1 times negative 2, which is negative 2. In my denominator, I still have an m to the negative 3 and an n. Now I have my quotient rule. When dividing powers of the same base, I subtract the exponents. I have m to the negative 4 minus negative 3. And then I have n to the negative 2 minus 1. That's going to leave me with m to the negative 1, n to the negative 3. Now both of those are negative, so they're going to come down to the bottom. This will be m to the 1. This will be n cubed. And then I need to fill in the space, so I just put a 1 on the top. Awesome. Last two, so these are meant to be hard. If you haven't practiced other questions first, maybe do that before you do these two, because this is just involving like power rules, quotient rules, product rules, negative exponents, all the things. So let's look at these. What would I do? Well, when I look at this one, my eye's drawn to two things. My eye's drawn to this 2 on this guy and this negative 2 on this guy. The 2 on this one I'm okay with. I actually think I would distribute it. So I would say that this is 3 to the 2 x to the 4 over y squared. So I multiplied all of the exponents by 2. But then for this other one, I feel like I would deal with the fact that it's negative first. So I'm going to flip it. So everything inside stays the same. It just gets put in the different place. It doesn't make this negative exponent positive. It just flips the entire fraction. Then I would deal with this power rule. So now I'm going to write this as 9 x to the 4 over y squared. And then this one, I would get y to the negative 4. Then this would be 4 squared, and it would be x to the 6, which is going to give me, shrink this down a bit, which is going to give me 9x to the 4 over y squared times y to the negative 4, which you could make positive if you wanted to, over 16x to the 6. Now, what am I going to do now? Well, I'm going to use multiplication of fractions. I'm going to multiply across. That's going to give me 9x to the 4, y to the negative 4, all over, I'm going to put them in the same order, 16 x to the 6 y. So now I get to use my quotient rule. And I've kind of run into the bottom of my page here. So I'll deal with the 9 and 16. Is there anything that goes into both 9 and 16? 3, 9. No. So this is going to change. Stay 9 and 16. And then 4 minus 6 would give me negative 2. Negative 4 minus 1 would give me negative 5. And then I would just write those with positive exponents. So the 9 and the 16 stay, and then the x squared comes to the bottom, and the y to the 5 goes to the bottom. So that my final answer would be 9 over 16x squared y to the 5. Again, you can choose a different way to solve those ones, but there are quite a few things in there. There's negative product rules, there's product rule, there's, I keep calling that product rule, power rule. There's negative power rule, positive power rule. There's the product rule when we multiply it across. There's the quotient rule when I divide. And it's kind of up to you when you want to use them. So why don't you pause the video and give this one a go. See what happens. Okay, I'm going to do this one the exact same way I just did that one, just for the continuity. So if I look at this one, I'm going to do the 2 through on that first fraction. Second fraction, I'm going to flip it to make the exponent positive. Whoa, those are some weird lines. Now this one's kind of nice because it's an exponent 1. So now I'm left with 4, which is 2 squared, and then I have an x and a y squared. And then the denominator, I have a 4, and I have an x to the 6 y. I've got 4 divided by 4 is 1, so that's gone. And I don't need that line. So 4 divided by 4 is 1, and then if I do my quotient rule, 1 minus 6 is negative 5, 2 minus 1 is 1, and then I want to make that exponent positive, so I'm going to put the x to the 5 in the denominator. How'd that feel? That felt a little bit easier than this one. But again, more than one way to do these questions. Totally, totally, totally up to you, as long as we get the same final result. Good luck.